I am glad to introduce Dr. Michael LaValley to present us today. He is professor of biostatistics at Boston University School of Public Health and the methodology core for the Boston Musculoskeletal Clinical Research Collaboratory. And he has been really I would say a bedrock. That's not the right word, but he has been really instrumental in methodology across arthritis and rheumatology studies for a while. I mean, just really an excellent methodologist and statistician, and has made amazing contributions to the rheumatology community and in rheumatology research. And so we're glad to have him speak to us today about optimizing high quality data analysis and research workflow.
Well, thank you very much for that introduction. I would say if something comes up in the chat that I don't see it, feel free to, Abby, to let me know if there's a question. And as we go along, please feel free to put stuff in the chat or ask questions. So I wanted to talk today about something that kind of comes into play a bit in my role as helping to lead the analyst team at the Boston CCCR. And before I get really started, let me introduce our center in a little more detail. I'm not sure everybody on here knows exactly who we are, but our focus has been mostly on osteoarthritis, pain, gout, and ankylosing spondylitis. And as part of our mission, we support a wide range of clinical investigators. We have people from academic medicine and rheumatology. We have people trained as epidemiologists, physical therapists, radiologists, biomechanists, people in public health. So it's a wide variety of different types of investigators who come to us, and we collaborate with. Many of them are at BU, either in the medical center or in the Sargent College, which focuses on rehabilitation and health sciences, but also from other institutions as well, including Northeastern, and we have, collaborators at the University of Texas. So there's a lot of, people local and, dispersed who we work with. Our intent is to perform high quality data analyses, leading to research publications. And the areas we tend to emphasize are epidemiologic methods. A big slice of that is causal inference. We have some people very focused on machine learning, mobile health applications, and again, another big slice of what we do is kind of what I would term as pharmacoepidemiology. And in terms of the analyst team, this is a group where I'm the co-lead with Reza Jafardas, who's a PhD in epidemiology. And it's a pretty good sized group these days. In the past, we weren't always as numerous as we are now, so it's great to have good numbers. So we have two MPH data managers, and we have two full-time master's biostatisticians as data analysts. We have two half-time research associate or research assistant doctoral students in biostatistics who are working in the center while also working on their thesis in the other half of their time. We have a person with a PhD in epidemiology and a computer science background, and a senior level MPH data analyst who also does administration with the team. And of course, our goal as the team, the analyst team, is to support the clinical investigators and produce scientifically sound research. And, for the most part, we're working with observational data sets. So typically I think of this, DAG here as our standard structure for most of our analyses, not all of them, but many of them, where we have, a specific exposure of interest. We've got a specific outcome of interest, denoted by Y, and we've got some potential confounders. I think of them as, common causes of the exposure and the outcome. So it's a pretty standard DAG. As someone who was trained, in the last millennia, we didn't talk about DAGs like this when I was in school. So I think it's a good way, though, to, summarize and, keep in mind what it is we're trying to do. In some ways, this is an innovation for me. I'm sure most of you have been trained using DAGs much more involved in this, but I do kind of find it appealing to use these. And usually we're doing analyses that are, a regression analysis. If we have a continuous outcome, it's a linear. More often the case, we have a binary outcome and we're doing logistic regression. And we might do Cox regression if we've got some kind of time to event outcome. Most of the studies we work with have some longitudinal aspect to them. So it's not that uncommon to have repeated measures or a time to event analysis. But I think most of our analyses are focused on binary outcomes. So, an investigator will initiate research by coming to us with a proposal. And ideally, we want it to include some kind of pre-specified statistical plan. And and this would be done before the investigators have access to the data necessarily. Now, many of our investigators have worked with the different data sets we work on a lot, so they do have some prior knowledge. But this is not intended to be something that they need to go in and look at the variable listings and things like that to do. But it should specify what outcome variable they want to look at, the predictor sets, which I'm thinking of as the exposure, and any confounders or covariates that they want to include. And, just a basic idea about what the model would be. Is it a regression model? Are they stratifying on any factors? Are they thinking about a mediation analysis or an interaction? That's the kind of more high level things that we would like to see in the research proposal. And also some idea of how the results from performing these different statistical analyses will, be interpreted in terms of pushing forward the research question that they're after. So fairly standard stuff. Now, what can happen, and this is, always unfortunate when it does happen, but there are some projects that really kind of get stuck in the pipeline. I'll talk a little bit more about the pipeline in a minute, but these are the projects where, everything starts off as typical, and then at some point they get bogged down. And usually this happens in response to there's some discovery of an issue with the data. It could be there's a lot more missing data in places that were unanticipated. It could be that there's something that wasn't really expected about the exposure or the outcome that is discovered and, create some challenges. It could turn out that even though we're usually working with large data sets, that by the time you winnow things down, if you've got an unusual exposure or an unusual outcome, that you really don't have enough subjects that actually qualify to do the analysis you'd like. It can also come from some kind of reversal of direction or some other unexpected analysis result. And we also often run into questions about, oh, should we standardize or normalize this variable when we're sort of knee deep in the analysis already? And all of these things can, basically lead to trouble in that all of a sudden a lot of new analyses need to be run. They get run, swapping out the exposure or the outcome, adjusting maybe for different covariates, stratifying when we haven't stratified before. There's lots of different ways this can go. But in general, it's sort of like you're stuck in a car on ice. And I know this doesn't necessarily resonate in everywhere like it does in New England, but the tires are spinning and the car just isn't moving. So there's a lot of activity going on, but really the research is at a pause. It's stuck. There's nothing going on. And this is really an unpleasant place for everyone to find themselves out in. The investigator will, of course, get frustrated that things aren't moving forward. The analysts are, running all these additional models and they're annoyed. So it's really not a good situation. In my experience, this log jam or stuck period will eventually break, but a lot of time and effort will have gone into getting through this period. So this is something I would really like to minimize as for our team. I've uh, worked with all of our analysts, and I definitely don't want to put them in this situation. And most of our investigators also. I mean, I've been around long enough that they were junior faculty when I first got to know them, or they might have been fellows or graduate students. So, I really appreciate everybody on the team and really don't want to put anyone through this. So, how can we kind of try to avoid this? And I should say that this is work in progress right now. This is what we're trying to implement and sort of standardize in our CCCR at this time. So the way we're approaching this is the research proposals are put forward by the investigators, and these are generally a couple pages long. They're not really necessarily standardized, but it should outline the research question and at the very high level kind of how they want to what variables they're thinking about using, how they're thinking about the analysis to go. This is then reviewed at our weekly we call them accelerator meetings. But this is an everyone attends meeting. All the investigators, all the analysts, everyone is there for the center. And at that point, if as long as the project is well reviewed, it gets then assigned to a member of our analyst team. And the analyst working together with the investigator who made the proposal will put together this analysis implementation plan, or AIP. And that's kind of the first step of, taking the research proposal and putting it into a form that the analyst can really work on. So this is the stage where things like exactly which variable are we using for this? Maybe the research proposal will talk about pain measured at a particular time point. The AIP should say exactly which pain variable is going to be used. So it gets more into detail and for many things like pain or function, there could be multiple variables. So this is a crucial step in getting everything fleshed out. And once that's been sort of thought through, the next check would be to look at feasibility. And for this, we're just thinking of rough numbers. And these would be presented not to the full accelerator meeting, but to a separate analyst meeting we have weekly. And this would look at things like what's the total sample size for this research. If you're looking at an exposure, it's often a binary exposure. How many people are in the exposed group? How many people are in the unexposed group? And how many outcomes will there be? And this is very, rough stuff, but we're hoping that by implementing this routinely, we're going to eliminate some cases where at the very end, the research has all been conducted and we're looking at the results and saying, why did we do this? Didn't we realize that the numbers were not really adequate for this particular study? And then after we've done that rough feasibility check, the next stage is the initial data analysis, and I'll talk more about that in over the course of the talk, because I do want to focus on this a little bit as, again, another quality check to implement before things move forward. And based on this initial data analysis, we can make changes to the analysis implementation plan as we discover new things. And then finally, we can kind of go into the phase where the research is actually carried out. And that's where the AIP is put into, it is given to the analyst and they move forward with it together, and certainly report on the results with the investigator. And then hopefully the results get written up and published. So that's what, of course, the end goal would be. So let me talk a little bit more about this initial data analysis. And the idea here is really just to try to get a sense of the gaps and weaknesses that are there in the data. So the rough feasibility check will tell us if there seems to be adequate data, in terms of the numbers anyway. But we want to look a little deeper for this initial data analysis. And in the past, people have talked a lot about exploratory data analysis. And when I was trained, that was a big piece of our training. You sort of went in there and sort of looked at lots of things and sort of on the go, you could almost tailor your analysis on what you found as you were doing this exploration. Now, that's in general, there's some problems with that. And this comes from a paper I'll talk about in just a minute. But really, at this preliminary stage, what we shouldn't do is anticipate the primary analysis. Because that's the situation where we can really introduce a lot of bias. If we sort of start messing around doing preliminary looks of exposures against outcomes and variables against outcomes, we can be misled. There can be associations in our data set that really aren't there if we were to look at the whole population. So it's really easy to, if you just do kind of an unstructured exploration of the data and move from that into your data, your full data analysis, you can actually pick up a lot of things that just don't replicate. And also, it makes it really challenging to document how you arrived at your final model if you do this kind of exploration as your approach. So, as an alternative, this paper recently came out. It's from 2024. It's from the Stratos Initiative. And this is an initiative that really thinks through how to do better analyses for observational data. And I think for me, I found this paper really very helpful in terms of clarifying some things about how to think about this stage of the analysis. And really, the key focus in the paper and what they propose here for initial data analysis is to allow us to get in there and investigate the data in a way that's leads still to reliable results at the end. And to allow us to be transparent about, any things that need to get changed on the basis of the results of this initial data analysis. So what the initial data analysis that they talk about assumes is that you already have, in some sense, a clean data set. It's not really about data cleaning so much. The ranges have been checked for the variables. Categorical factors don't have values out of bounds. Everything otherwise seems to work okay. And that there's some data dictionary so that we know what should be measured in each of the variables. So this is kind of the stage we typically have for our data analyses. And the emphasis in the paper is multivariable regression, which is 90% of what we do anyway. You have a single well-defined outcome variable, hopefully. And you have a few what they call in the paper structural variables. And these are variables that have very little missing data. And usually they're linked somehow to either the data collection or they're linked to key features that everyone, that are sort of uniformly collected. So things like age and sex, things like that could be these structural variables. And the reason they're important is because they allow us to look at other things that are a little less common, that may have more missing, and make some determinations about those other variables. And also, we have some just predictors that we're interested in. Maybe certainly our exposure would be one of those, but also any key covariates we're thinking about. So, for the IDA, it's again not intended to be an exploratory data analysis, and that we're going to be restricting how we use the data. And we're going to kind of stay away from looking at associations with the outcome. And that's really the place where exploratory data analysis can get into trouble because you can find things that seem to be associated with the outcome in your data that, won't be in another person's data set. But we do want to make sure that the IDA pays attention to the research question because it's really, it's only the variables that are involved that we really need to focus on. So things we want to look for, and again, this would be focused on the exposure, the outcome, the key other predictors would be, what's the pattern of missing values? Are there, are there issues with some variables having, far more missingness than we're really anticipating when the research proposal comes together and the AIP is thought about? What are the distributions of the key variables, including the exposure, the outcome, and these predictors? There may be things there that we don't fully appreciate before we get started on the IDA. Also, we can look at this point among the predictors for collinearity. We don't really want to look at associations with the outcome, but among the predictors we can look. And this may be a way for us to think about model building. Are there measurement errors that just seem to be there that we weren't anticipating? Another thing that often comes in, I know we work with multiple data sets in our group. A lot of most analyses, of course, but also other data sets as well. And sometimes the way data are collected, there may be some kind of a skip pattern, either in an instrument or in the way the data are collected that we don't necessarily realize in advance. If a subject is asked about pain, then they probably, and they say no, they don't have any, they probably won't be asked about the location of pain. So if we, immediately jump to looking at pain in the ankle, we may see a lot more missingness than we expect, partly because many people are just not asked about pain in their ankle because they're reporting no pain at all. So rather than treat them as missing, we should say, well, they're reporting they have no pain. But this is the sort of thing that, unfortunately, we can't always catch in advance. So this is one of those places where the IDA can be helpful. So the IDA plan should focus on those things. It should look at the missing values. It should look at the distributions on a univariate basis, and it should look for associations among the predictors. But it should make, again, this is to my mind where the exploratory data analysis usually falls down, is you really do want to stay away from looking at associations between the predictor and the outcome. And the plan for the initial data analysis should include some ideas about, how we might modify our analysis implementation plan, depending upon what we find when we do this initial data analysis. If we find too much missing in some predictors, we may have to rethink including those predictors. If we find predictors that are really unbalanced, so this would be a binary predictor with very few events or very few, very little variation in outcome in the values. Or continuous predictors where you've got really a tight range of values and then all of a sudden some huge outlying values that aren't necessarily things that you can just ignore. So those kind of concerns may lead us to say, well, if 95% of the people report no on this question, it's probably not a fruitful question to include in our analysis. Things that are just too unbalanced to actually be helpful. And when we look at correlation or associations among the predictors, we can maybe get rid of some redundant predictors. And once we've gone through that analysis, we can then update the AIP. And we can, within the AIP itself, the implementation plan, we can specify what's been changed on the basis of this initial data analysis. Just as a quick example, suppose we have a predictor we're thinking about using that's a categorical factor, it has 4 levels, and as part of the IDA, we look at the frequency of each of the levels, and we see that really only 3 of the levels have a meaningful number of responses. One level is more or less blank. So if we were to, do a logistic regression, typically that would be our regression here, and we use that as a predictor, we're going to probably end up with a complete separation because, with so few people in one category of a predictor, there's probably going to be, no people who have the outcome or everybody has the outcome within that group. It makes that situation of getting a likelihood that's unable to be maximized. It makes that much more likely. So, we could collapse that 4-level predictor down to 2 or 3 levels, depending upon the frequencies we see. And that's something, again, it could be put in the IDA, the AIP, to say, we changed how we coded this variable on the basis of this initial data analysis. But this is the kind of thing that, if we hadn't done the IDA, we might get 90% of the way through the analysis or 80% of the way through the analysis, and all of a sudden we're trying to figure out why things are looking so strange. Why things aren't working at all. So this is from that paper from the Stratos Initiative, and they sort of discuss different workflows based on including an initial data analysis or not. The path A, the one over here on the left-hand side, is the exploratory data analysis path. So basically, someone gives you the research proposal, you mess around with the data, get to the point where you just keep doing that until you come up with the results you're going to present and interpret. Path C is the one on the right, and that's where you're given the research proposal, and then you just kind of straight away implement it, and without doing any kind of check on the variables. And then the path B, the one in the middle, is the one where you do you develop the analysis strategy, you do the IDA, you look at the results of that, and then you update the analysis plan. And then you move into the real phase of statistical modeling. So just to give a little more detail on what these IDAs might look like, this is from that paper, and they had different structural variables that they were using in their analyses. So they had age and sex. But also for us, working on, say, the MOST study, we might think about, what's the radiographic OA status? That's something we should have on everyone. Um, if we're thinking about analyses of, something like maybe the Framingham Heart Study, where we've got multiple cohorts of subjects across generations being brought together, which cohort do they belong to? Again, that's something that should be it should have no missingness, and we should be able to link other things to that. So, these were the prerequisites for the IDA, in terms of, what you need to have. You need to have a research plan. You need to have some kind of initial analysis strategy. You need the data dictionary, and you need domain expertise in that. So when you find these issues in the data set, you can, discuss with the investigator and, see how they can be overcome. In terms of the specific domains that are accomplished during the initial data analysis, the missing data check is a big component. And, with the kind of data we deal with, where we've got repeated exams, certainly in the MOST study or the OAI, we have to worry about, missingness at the sort of patient visit level. Did some of the participants just not come to exam 3, but they were there at exam 2 and exam 4, things like that. So that would be unit missingness. And also within an exam, we could have people who, maybe the time runs out during the exam, and that certain things don't get done. It also could be patients don't want to do the chair stand, so that's missing. So there could be, missingness both, for the whole exam for a patient, as well as, they have most of the stuff for an exam, but a few things missing within it. Um, and again, looking at patterns is important because that will help us figure out things like skip patterns. And, are there groups of people who might be missing more often than other people? Or is it older participants who we don't have values for? Is it, do the men refuse to do something? So things like that, we can explore a bit in the IDA. And I mentioned we want to look at rough numbers in the feasibility assessment, but as part of this missing value assessment, we can look at a more granular level how much data there are. If you just look at the outcome on its own among people who are eligible for the analysis, how many outcomes do you have? If you include the outcome with the key structural variables, which should have very little missing, how many people do you have? If you include the exposure, how many people do you have? The most important covariates. Again, you can sort of get a sense of how the numbers are shifting as you put more and more of the variables in the analysis. And this may help us to think about the missing values. Help us think about, do we need to do multiple imputation? Do we need to take some measure to address missingness? If we've only got, say, less than 10%, maybe we don't need to. But if the complete cases are less than 90% of all possible cases, then we may want to do multiple imputation or some other approach to deal with the missingness. In terms of the univariate descriptions, categorical factors, it's just a matter of looking at the proportions in each level. For continuous variables, we probably just want to look at the distribution, get a sense of, is it very skewed? Is it not so skewed? And and really with continuous predictors, the question would be, especially for a lab value, do we need to log it or do some other transformation? And this just shows some of the transformations that they considered in their paper. They were looking at quite a few lab values, and you can see that, like for the top figure there with the creatinine kinase, it, if you don't do a log transformation, it's really hard to do much analysis with that variable. Now, in the paper, they actually talk about using something they call a pseudo-log transformation. If you're interested, please check out the paper. It's kind of interesting, but typically, I've found that even just taking a natural log or a natural log plus of the value plus one will accomplish a lot of what I need to do. And then the last bit is sort of looking at the association of the predictors. Um, and we can do this by hopefully visualization is usually the way to best think about this. Gives us a much better sense of what's going on than other approaches. But we can look, for continuous predictors, we can look at correlations, we can look at associations for categorical factors. Um, if there are interactions called for, it may make sense to look at them in this stage. If the research proposal it was discussing using interactions, this would be a good time to look. Um, what you don't want to do is do multivariate analyses with the outcome. So you can do missingness evaluation of the outcome, you can do univariate, but this is the step where you would just stick to the predictor values. And sometimes we think about nonlinearity, in which case we probably wouldn't want to use Pearson correlation, but more Spearman correlation. So this is just one example from that paper where they were looking at the BUN values, and gonna try to move this out of my way. Um, Yeah, so they're using the structural variables of age and sex, which again have no missingness, to sort of look at the distribution of these of this particular continuous measure to see if there are things they need to address. This is looking at um, the sort of the multivariable correlations with a this is an R figure, looking at the Spearman correlation across all the different variables they're considering for the analysis. And in the figure, the blue squares correspond to correlations that are positive, the red squares correlations that are negative, and the brightness or the fading is linked to the strength of the association. And for the ones that are sort of in the deeper blue here, the ones with the stronger positive correlations, they went ahead and did scatter plots. And we can see that these variables are indeed quite strongly linked. And so we probably wouldn't want to include all of these variables. We'd want to pull out some of these that were strongly associated with other ones and not use all of these. So the whole point of doing the IDA is to make everyone familiar with the data. Um, and on the basis of that, we may modify the initial AIP or analysis plan to sort of account for some of the things we found in the the initial data analysis. So if there's a lot of missing data, we may have to consider imputation strategies. If we find categorical factors with very few levels, we may have to think about combining categories. And should we transform variables before we launch into the full scale analysis? And also, should we remove some? And the nice thing about doing this with the initial data analysis approach is at this point, we really haven't done anything with the outcome. And so, we aren't making these changes in ways that are going to enhance our association with the outcome. Because at this point, nothing, we're really kind of staying away from the outcome other than in a univariate manner. Um, so we can put in the AIP that we've made all these changes, and we didn't do it to just enhance the way our final model looks in terms of explaining the outcome. And once we've gone through that process of the initial data analysis and updating that analysis plan, the AIP, we can then go ahead and launch into the formal data analysis. We can start doing our regression analyses and doing the sensitivity checks we would normally do there anyway, but we do it with a better understanding of what the underlying data are like and where some of the potholes may lie. What weaknesses are there in the data? We have a better sense at this point. And I think, this is, I think to be borne out, hopefully in the future, that if we go through this exercise of, checking out the data at this level, then we're less likely to go off on tangents later. By the time we get to the formal data analysis, we understand the data. They aren't going to come as a surprise. Any limitations in the data won't be a surprise that, kind of crop up when we're doing multivariable modeling. Now, what's the cost of doing this? Um, well, we're building in an additional step in the research workflow, and it takes some time for an analyst to go through, especially if there's a lot of variables involved in a research proposal, to go through and look at all of these things, and then think about how to address them in the analysis implementation plan. And this does mean that really all proposals are going to take a little longer to go from, the initial research proposal to the final product. Um, but I think the benefits here are that we're going to, hopefully for these projects that do hit that, that place where they start to churn and not progress well for a period of time, that this will be minimized. That kind of thing will happen less frequently, and hopefully, when it does happen, will be for a shorter duration. Um, so I think it will reduce some of these wasted cycles that we hit in research, analysis. And I'm hoping that it's in particular the proposals that the initial data analysis flag some issues that will be sped up. The other thing I think that's a huge benefit here is I think this will give us more rigorous and defensible uh, results at the end because, there will be a lot less feeling that, maybe you've made some changes to enhance the R squared or the p-values for your final regression model. Um, if somebody is combining levels of a predictor and they're doing it at the last stage, then I think, that does open the question of, are they doing it just to make get a p below 0.05 here. And I think if we do this outside of that setting, that will allow us to make these decisions in a lot more defensible way. Now, I don't want to say that this initial data analysis is never done anyway, because there are a lot of good analysts who do most of this stuff routinely. Um, but I think there aren't so many that do it all the time. And, all of those different stages. And I think having this as part of the workflow will hopefully ingrain these good practices, and that will allow us to sort of be more confident when we get into the modeling phase of the analysis. When we start really doing the regression modeling, that we understand the data, that we are not making decisions based solely on trying to get the p value below 0.05. The downside, of course, is that it will be an upfront investment in time, and it's not going to make proposals move more quickly through the pipeline. Um, but I think, having been involved in research where we've gotten into those late stage kind of problems, I think reducing that is a big advantage for this. We really don't want to feel like, the analysis is 90% of the way complete and then find this kind of gotcha in the data, and have to start doing things over again. And I think ultimately it will increase the quality of our output. And, that's what we all want to do. We all want to be involved in high quality science. That's why we're here and doing the things we're doing. And I think all of us as investigators and analysts have felt, a little under the gun with all these publications and, articles that have come out about how, it's hard to replicate scientific results. And I think paying a little more careful attention to the workflow, even though it means increasing the amount of process, I think will help us to be both more transparent and more reliable. Okay, so that's be happy to address any questions people have. I can stop sharing.
Everybody, feel free to come off mute or put something in the chat if you have questions.
This is Becky. Hi, Mike. The great presentation. Thank you so much. I just have maybe a question or observation. So you mentioned that adding all of this stuff to the workflow is definitely going to increase the amount of time.
Yeah.
So I know that as you know, that a lot of times you have investigators who come to the analysts and want something done right away, and so what kind of pushback do you think we'll get from the PIs on these kinds of things?
Yeah, I think that's a great question because you're right. It's often, we definitely do have to deal with investigators showing up at the abstract deadline is next week. I need to have this done. It's a problem. I do think we need to push back against that in general and just say, look, if you want to have good quality results, we really need to be talking earlier. But yeah, there's always going to be those cases. I mean, I'm hoping that we can, by implementing things like this, try to get people to us earlier in the process. But yeah, I agree. That's always going to be a challenge.
Thank you.
I'll ask sort of a related question is how you might advise particularly early career people, researchers who might not have as much opportunity for statistical support, which I know we're all talking here as a group of CCCRs whose mission is to help people often in that situation. But I think even in those scenarios, people, there's variability in how much statistical support they might be able to get from our methodology course. So are there any ways you would advise that you could do this process that, like, say they can't do the whole, all of what you're advising? Are there ways that people might be able to apply this in a way that if they don't have as much upfront resources or time, that they could still do some of this in ways that makes it more rigorous or it creates less or identifies problems earlier? Like what would be the priorities to you?
Yeah, well, I do think the feasibility step is crucial, and looking at just the numbers. I mean, because people will often come in with these wonderful sounding ideas, but when you start looking at them carefully, there's very few people in your sample who are going to be able to address what they really want to talk about. And that's something that there's really nothing analytic you're going to be able to do to help. Beyond just pointing out, look, you maybe need a different sample than what we've got. Um, but yeah, I do think also looking at missing data is a key component of this. I do think even, if you're doing a fairly quick and dirty kind of approach, getting a good sense of the number of complete cases, because often, if things are rushed, often it's going to be a complete case analysis that comes out of it. And having a good sense of, are we talking about 90% of the, relevant sample? Or are we talking about 50%? What's going to be coming out of that. Um,
All right,
Yep.
thanks. And Louise says, I think the process lays out a nice framework. Um,
yeah, yeah. I think
Yeah.
if trainees also, if they sort of try to follow that the paper and think about those stages, I think it will help them.
Dr. LaValley, my name's Cody. I'm a navigator for P30 in Indiana. And it's thank you for your talk because it's good to know that there's other people experiencing bottlenecks like we are. Regardless, I just kind of a simple question. We have a lot of investigators interested in propensity analyses,
Yeah.
specifically control matching. I was hoping you can maybe touch on if you've experienced that and how you approach that, where in your data process, if you just give them the data and have them do it, if you help them, kind of where that falls in your schema as well.
Yeah. Well, in a lot of our pharmacoepi analyses, that's a big piece is case control matching or propensity scoring. And it's challenging because it's in itself a statistical analysis to do a propensity scoring. And it's often a very multivariate analysis looking at there it's who's receiving treatment as your outcome typically. But yeah, so if they're doing something like that, it really does, make this more important, I think, because you really do have to do this analysis in multiple stages, and your end result depends on getting that propensity score model in a good shape. So I think, issues of missing data and factors where, 95% of the data are all coded as zeros, those are going to show up. And that's so it makes it, if anything, a little more important, I think, in that setting.
I had a couple questions and appreciated the talk as well. Um, I'm curious how like your method section of a publication that would result from this type of workflow, how does that look different than say if it were either of those other paths, the exploratory data analysis or something that's sort of completely pre-specified. And then
Mm.
the second part of my question is, you mentioned a little bit of the structure of your team, and particularly in terms of the like the master's level statisticians and maybe
Mhm.
the PhD student RAs that you have. How do
Yeah.
you typically try to approach funding for their time and effort?
Yeah, well, I yeah, I gotta say, in terms of funding, that's a little outside my usual realm of activities. I stay away from budgets as a rule. But yeah, I think it's, it of course depends on the grant funding. But we also house the most study, and I think that does allow us some ability to fund people at the master's level and our PhD students as well. Between that and the CCCR, we've been able to put together some funding for people, which has been really great. I'd have to say that having been in the situation where we've had many fewer analysts on the team before, I think being able to have multiple people, involved in projects at varying time points has been really, really very beneficial. Um, we don't always want the same analyst working with the same investigator all the time. I think it's much better if we can swap people around. People come in at different stages of the process and can, view the programming that's been done by other people and maybe even catch some problems. So it's been, I think it's worked very well. And you were asking about the method section also. Yeah, so I mean, I do think it's important to try to be as transparent as possible. So my method sections probably are longer initially than what get published, and at some point people, either the editors or the co-authors will say, look, you've got way too much detail about this, rather refined point in your method section. So, I mean, but I do think being transparent is important. So I think if you've done a fully exploratory analysis, I think you really have to say that, that this was not so much pre-planned as, we went with the flow, so to speak. And if it's fully pre-specified, you can certainly say that as well. But I do think there's some room to say we did, data exploration as part of developing the analysis, focusing on these factors and, avoiding pre-doing the analysis that way.
Thank you.
We have one hand up, Paul Nieder, and then I think that'll close us out, but we have time for that question. Thank you.
So I was just curious, occasionally you come across like a clinician or maybe like a psychologist or somebody who has a lot of quantitative skills and they want to do their own analyses or at least play a role in that. I'm just wondering how you handle that.
Yeah, it's good. I mean, to have that in some ways, and it's painful in other ways, right? I think we've all had that experience where somebody has run with an analysis and we've, been a little horrified at the, what came out. I think it's you don't want to feel like you're the barrier, as an analyst, as a, leader of a team of analysts. I don't want to feel like I'm impeding people from doing good research. But on the other hand, I need to make sure the research is good. So I do try to channel them through analysts and have the analysts provide quality control for that. I mean, I do think it's important that somebody who's a data professional, is looking at things at various points of the analysis.
Thanks.
All right. Thanks again, Mike, and thanks for everybody for attending and asking great questions. And I think we will close here.
Well, thank you all
And I think the recording will be available.
for your questions.
Thanks, Mike.
All right. Good to see everybody.
Bye.
Bye-bye.